Okay, today we're going to talk about solving radical equations. So at the top it says a radical equation is an equation that contains a radical expression with a variable in the radicand. So remember, radicand just means that that's what's inside. So we're going to have an equation that has a radical with a variable inside. So to solve a radical equation involving a square root, first we're going to use the properties of equality to isolate the radical on one side of the equation. Okay, so that's step one, isolate the radical. Then we're going to use the following property to eliminate the radical and solve. So what it says next is if two expressions are equal, then their squares are also equal. So if a equals b, then a squared is b squared. So here's what that means when we're solving these equations. Okay, so like on letter A, step number one is going to be, let me see if I can zoom this in. There we go. Step number one is going to be to isolate the radicand. So we're going to subtract 5 from both sides. So I have the square root of x equals 13 minus 5 is 8. Okay? So once I have it down as the square root of x is 8, okay, like that's awesome that that's the square root of x, but I want to know what x is. So I can square this side, okay, but then I have to square the other side. If a equals b, then a squared equals b squared. Okay, so if the square root of x equals 8, then the square root of x squared equals 8 squared. So when I take the square root of x squared, that gives me x, and then 8 squared is 64. Okay, and it makes sense because the square root of 64 is 8, and then 8 plus 5 is 13. Okay, so let's look at letter C. The radicand, is already isolated. So all we have to do is square both sides. The square root of x squared is just x. 6 squared is 36. Okay, on the next one, we're going to isolate the radicand. So the square root of y equals, I'm subtracting 15, 7. Then we're going to square both sides. So y equals 7 squared, which is 49. Okay, on letter B, same thing. We're going to go ahead and we're going to isolate the radicand. So to get rid of this 3, I am going to subtract it, right? Remember, if I wrote plus 3, 3 plus 3 is 6, and that didn't eliminate anything. So now I have the negative root of x equals negative 3. So essentially, that's just like saying negative 1 times the square root of x. So I'm going to divide everything by negative 1. So the square root of x is 3. Square both sides. X equals 9. Okay, on letter D, we're going to isolate by adding 7. The square root of x is 10. I added 7 to both sides. Then we're going to square both sides. So x is 100. The square root of 100 is 10. 10 minus 7 is 3. Okay, so why don't you do letter F? Okay, try letter F on your own. So if y'all are watching together, you can pause it. If you're watching on your own, you can pause it. And then once everyone has a chance to do it, you can come back and check your answer. Okay, so when we isolate, we get the negative radical of C equals negative 3. Divide everything or multiply by negative 1, either way. So, the square root of C is 3. So C would have to be 9. Because the square root of 9 is 3. Okay, so here's where I messed up on the notes. You'll notice this is all the same as up here. So your next section is actually on the back. We're going to start with G. Okay, so is the radicand isolated? Is it just the square root of x or the square root of something? Yes. So we're going to do the same process. We're going to square both sides. So the square root of 2x minus 1 times the square root of 2x minus 1 is 2x minus 1. And then the square root of x plus 4 squared is x plus 4. Now it's just a regular equation. Okay, I have variables on both sides of my equal sign. So I'm going to go ahead and subtract x from both sides. So x, so I kind of did 2 steps in one. I subtracted x and added 1. So x is 5. Okay, if I plugged it in, 2 times 5 is 10. 10 minus 1 is 9. The square root of 9 is 3. If I put a 5 in here, 5 plus 4 is 9. The square root of 9 is 3. Okay, so on letter H, we have to isolate the radicand. So I'm going to subtract 7 first. So the square root of x plus 2 equals 4. Now I'm going to go ahead and I'm going to square both sides. So x plus 2 equals 16. Subtract 2, and x would be 14. 14 plus 2 is 16. The square root of 16 is 4. 4 plus 7 is 11. Okay, on letter I, it's already isolated, right? It's a radical equals a radical. So all I have to do is square both sides, square and square. 3x plus 1 equals 4x minus 7. Okay, I want x by itself, so I am going to subtract 3x. So 1 equals x minus 7. Okay, you could go the other way and subtract 4x. You'll get the same answer. And then I'm going to add 7 to both sides, and I get 8 equals x. Okay, so let's talk about what happens when it's a cube root. Okay, some of you may have already guessed it, but we're going to cube both sides. If it's saying the cubic root of 5x minus 2 is 12, then I'm going to go ahead and I'm going to take this whole thing and I'm going to cube it. And if I cube one side, I'm going to cube the other side. So on my calculator, well, first I can do 5x minus 2 equals, on my calculator, I'm going to do 12 to the third power, and I get 1,728. So now it's just a two-step equation. I'm going to add 2 to get 5x is 1,730. And then we're going to divide by 5 to get x equals 346. Okay, if we really wanted to check it out, what you can do is, we've taken the square root before by using this key, but we can do, I think I hit the 3 first and then this. So it's like saying the cubic root of x, or the cubic root of something, right? So I'm going to do the cubic root of 5 times 346 minus 2. And when I hit enter, I hope I get 12. Oop, just kidding. Maybe that's not how you do the cubic root. I said that, and now I'm confused. So let's see, cubic root of 125. Oh, so it is right. Okay, so then maybe I messed up here. So let's try one more time. So the cubic root of 5 times 346, maybe I should do that in parentheses. 5 times 346. Oh, I know what I did. Maybe. And then we're going to subtract 2. There we go. Okay, so that is our correct answer. Okay, on the next one, we have to isolate first. So we're going to add 4 to both sides. So the cubic root of y is 5. So now I'm going to cube both sides. 5 cubed is 125, and that's my answer. So the cubic root of 125 is 5, and then 5 minus 4 is 1. So on this last one with a cubic root, what we're going to do is cube both sides. So 3c plus 7 equals 10 to the third power is 1,000. If you weren't sure, 10 to the third, right? 10 times 10 is 100, times 10 is 1,000. So now we're going to subtract 7. So 3c equals 993. And then we're going to divide to get c equals 331. And that would be my answer. Okay, so the last thing we have to talk about are what are called extraneous solutions. So what I'm going to do is I'm going to show you one, and then we'll talk about what it means. Okay, so on this one, right, this is isolated. So I'm going to square both sides. So now I have x squared equals x plus 6. Okay, that's all fine and dandy, right? So we know how to solve this. I want to move everything to one side. So I'm going to have x squared minus x minus 6 is 0. You could do quadratic equation, completing the square. You could graph it. Or for me personally, when I'm looking at this one, it's pretty obvious to see that this factors into x minus 3 times x plus 2. Because negative 3 times 2 is negative 6, but negative 3 plus 2 is negative 1. I would set each of those equal to 0, right? X minus 3 is 0, and x plus 2 could be 0. So x could equal 3. I should have written or x could equal negative 2. So now what we need to look at is, does it make sense that the square root of this could be a negative? No, it's not asking for a negative root, right? So like, let's plug it in. So if I said negative 2 plus 6 is 4, is the positive root of 4 negative 2? No. So this is an extraneous solution. Okay, it's not asking you for the negative root, it's asking you for the regular square root. So this doesn't work, so x is just 3. Okay, let's look at the next one. When I square it again, right, I get 4 minus 3x equals x squared. So for me, I'm going to pull everything over to the x squared side. So I'm going to add 3x, plus 3x, then I'm going to subtract 4. Minus 4 is 0. So in order to make negative 4 and positive 3, I can do x plus 4 and x minus 1 is 0. So x would be 1 and negative 4. But it doesn't make sense that a square root is a negative. So I'm going to go ahead and get rid of that guy, right? 4 minus negative 12 would be 16, but the square root of 16, the positive root of 16 is 4, not negative 4. So on here, if I have a 1, 4 minus 3 is 1. The square root of 1 is 1. So that one makes sense. Okay, let's look at the next one. Okay, to isolate it, I get the square root of 5n equals negative 10. Automatically, this is a no solution. We're not going to have a positive root equal negative 10. Okay, and if you're confused, you might be thinking that earlier in the year we talked about how numbers had 2 square roots, and we did, but that would be like, so if you're just given the square root of 25, right, that's positive 5. If I asked you for the negative root of 25, that's negative 5. This isn't asking you for the negative root, it's asking you for the square root, just the regular root, and it can't be a negative. Okay, let's talk about this last one, because this one's the hardest. So we're going to square both sides. That means I have to square this whole situation, which means I'm going to FOIL it to get p squared plus p times 1 is p plus 1 times p is p. So 2p plus 1 equals 7p plus 15. Okay, if you have no idea what I just did, sorry, I went kind of fast. I just did p plus 1 times p plus 1. P times p is p squared. 1 times p is 1p. The outsides, p times 1 is 1p, and then 1 times 1 is 1. So p squared plus 2p plus 1. Right? All these things we've been learning don't just go away. Okay, we're expected to kind of like be able to draw on them for other things. So now I need to get all of this on one side of my equal sign. So I am going to subtract 7p and subtract 15. So subtract 7p and subtract 15. So what I end up with is p squared minus 5p minus 14 equals 0. So what can I multiply together to get negative 14? That's going to add to give me negative 5. That's going to be p minus 7 times p plus 2. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. So my two solutions are 7 and negative 2. So if I put a 7 into my original equation, 7 plus 1 is 8, so that works. If I put in a negative 2, negative 2 plus 1 is negative 1. Can I have a square root equal a negative? No. So that's an extraneous solution. Extraneous just means like extra. Okay, it's a solution that we get that doesn't actually work. It's not really a solution.